Welcome to this, the third in a series of instructional videos geared towards those who are new to modular synthesis. This is Glenn Rudolph from Reindeer Music. This video features equipment manufactured by Pittsburgh Modular Synthesizers and IntelliGel Designs. Generally, there are two ways to go about creating new patches with a modular synthesizer. One is to randomly patch modules together and adjust their controls in order to explore the results, and there certainly is virtue in this approach. It can lead to unusual, interesting, and unexpected results. But there are times when you already have an idea of the kind of sound you're looking for, and in order to create that sound in an efficient manner, you need to understand how modules behave when they're patched together. The usual traditional way of clocking a sequencer, for instance, is to simply use the square or pulse wave of an LFO. But what if you're interested in an irregular or a non-metric clock signal to drive the sequencer? There are more esoteric modules available that can do this for you, but there is virtue in knowing how to accomplish it using only basic synthesizer modules: LFOs, sample and hold, and voltage-controlled LFO modules. In the block diagram being displayed, enclosed within the dash box is the portion of the patch that generates the irregular clock signal, the irregular clock engine, so to speak. The key components are the sample and hold and the VCLFO modules. The control voltage being sampled can be an LFO waveform, as long as it's something other than a square or a pulse wave, a noise source, or an envelope that can be set to cycle. As you'll see when we run the patch, the irregular clock signal is determined and therefore somewhat controlled by the relationship between the sample and hold clocking rate coming from LFO2 and the LFO waveform, or the envelope 1 shape, and its cycle rate. When using a noise source as the sample and hold input, routing it first through an attenuator gives us the ability to control the maximum voltage available at the sample and hold input. Switching over to the patch now, the idea behind this patch is to supply discrete but varying voltage levels to the IntelliGel Dixie VCO, which is set to be in LFO mode. The Dixie VCO is supplying the clocking for the Pittsburgh modular sequencer, and through a multiple is also triggering the envelope generator. So by supplying varying but discrete voltages to the Dixie's linear FM input, we can cause the Dixie to clock the sequencer and trigger the envelope generator at correspondingly varying rates. Now, the Pittsburgh Modular LFO2 is particularly useful for this because the first LFO here, the triangle output can be adjusted, the shape of the wave can be adjusted from a ramp through a triangle to a sawtooth waveform. That's one part of the control that we have over the output of the irregular clocking signal. We can also adjust the cycling rates between the two LFOs, the clocking signal coming from the bottom LFO, and the speed of the triangle wave coming from the top LFO. Now, as we saw in the block diagram, another voltage source for the sample and hold circuit typically can be noise. In the case of the toolbox module, which has the sample and hold from Pittsburgh Modular, the noise source is internally patched to the sample and hold circuit. So if we remove the triangle wave as an input, we're automatically then restoring the noise source as the source of the sample voltage. Of course, now the only control we have over the resulting irregular clock signal is the rate of the clocking of the sample and hold and the base rate of the Dixie VCLFO. However, if we patch an attenuator between the noise source and the input of the sample and hold, we gain some additional control. So I've got an attenuator over on my auxiliary rack, and what I'm going to do is patch the noise source out, run it through the attenuator, and then return it from the attenuator to the input of the sample and hold. And then by adjusting the attenuator, we can limit the maximum voltage that is presented to the sample and hold input. Hopefully this video has given you some idea on how the basic modular synthesizer modules can be patched together to create more complex results. In this case, an irregular non-metric clocking signal. Check back at the Pittsburgh Modular website and at reindeermusic.com for additional videos in this series.